My name is Daniel, and I'm a software developer at Europol in The Hague for the last 3 years. In my spare time, I try and I like to play with new technologies, .NET related, which is not so hard because there are a lot. And explicitly, I like to play with IoT and machine learning, most of the time together, because it's a challenge to run machine learning or deep learning on IoT. Microsoft ML.NET, it's a new framework which allows us to do that. But this evening, I will focus on what's new in this new release. If you made a quick search about ML.NET, you will realize now it's 3.0, and it's only a couple of months past .NET Conf, but the things are evolving fast. And of course, they have some important reason why they released already 3.0 preview, of course, so they are still investing a lot of work on it. So what's new? Microsoft ML.NET, it's not specifically related to .NET 7, but it was launched together with .NET 7, so it was part of .NET Conf last year. And there are 3 important things which were released then. So it's text classification, an improved model builder, and improved AutoML. We will talk about them soon. And at the end, I hope I will still have some time to show you a few tricks how you can improve the accuracy of a machine learning model. And that's the secret we have without having data science knowledge. Just a quick question. How many of you have data science background? Good. And knowledge, data science knowledge, let's differentiate. Yeah? Good. Now, for the rest of you, this is very important because you will realize you can start play and create your own models without having knowledge. Of course, it will help to figure out things, to know how to read the measurements, the scores, but still, it's not mandatory. So, why is important ML.NET? Well, because we are .NET developers and we don't like too much to learn another language. We are working with a lot of languages. Let's enumerate a few, right? Well, more or less languages, right? It's SQL, it's JavaScript, it's what else? TypeScript, it's PowerShell, it's a lot. We don't want Python. Python, it's good, but for .NET, it's like, wow, not very. I have the same feeling like working with JavaScript. Like walking on moving stones, you know. Well, so we like to stay in .NET ecosystem, to not mix things. So what else? Microsoft ML.NET, it's code first. That means you can build your own pipeline to train your models. It's not like calling services. It's not like cognitive services or some other Azure services. It's on-premise. You can put it on Raspberry Pi and train and predict. So first feature released is text classification. Maybe this is a little bit confusing because we kind of have something like that, but it was not in a deep learning fashion. It was in machine learning fashion. I mean, it was converting text to tokenize text and do some machine learning classification. But this text classification, it's using BERT model, which is a deep learning model with multiple layers. Machine learning is one layer, right? But deep learning, it's multiple layers, it's different beast. So a few characteristics. As I said, it's using NAS-BERT, which is a variant of BERT, by using TorchSharp, which is another library developed by Microsoft, which is integrating with ML.NET. But again, we don't have to learn Torch. I want to let you know, TorchSharp is syntax compatible with PyTorch. And that's a good thing. If you have knowledge with that, you can easily migrate and write the same code. To port the same code, it's easy because it's syntax compatible. You know, it's not a naming convention as we know it in C#, but it's Python-like if you want to write code in TorchSharp. So, how is this different? We have a pre-trained model, and we are using a frozen version of this model, and we are doing the last part of the training. It's like fine-tuning, right? The training with the last layer of classification. And I will give you an analogy, if you don't have too much knowledge on deep learning. Now it's very popular, the inception model, which is able to do image classification. Well, it's the same. It was trained with millions of images, but it can be this model muscles can be borrowed to train for a subset of our own images and to classify in our classes, but which are a better fit for our problem. For example, we want to classify some food categories. We don't want to classify on each type of class. Originally, Inception was trained to classify in 1,000 classes. Well, it's too general for us, maybe. So it's the same here. Maybe we don't want to classify a sentence, but only to our reduced number of classes. And for example, I will use today a data set which is able to classify a quiz in 4 categories. So it's either physics or chemistry or math or biology. So these are 4 categories, and it's fine for me. I just want to do this classification. So what we can do is to provide our own data, our own text, and to do this transfer learning and finishing the training in order to instruct our model to recognize our classes only. So this is what we are doing. Of course, we can use the original model to predict some other things, but a good use case for us would be this to classify from this quiz. Well, another thing which we can do is to predict some sentence similarity, another classic scenario, or to do the tokenization, allowing to bring some vocabularies from other more powerful models. Now, maybe it's a good question. We have now GPT-3, yeah? Why we need BERT model? Well, it's more specialized. So if we want to try for a subset, we cannot use GPT-3. That's very general, yeah? You can ask virtually anything. But if we like to do something specific, we can get better results by training our model with a good data set. It's everything about data. If you have garbage in, garbage out. Bad data set results in a bad model. Or, as I like to say, in machine learning, the data is the engine, not the algorithm, but the data. The data dictates the algorithm. Then it's Model Builder. With this release, Microsoft released a newer version of Model Builder, which includes, of course, text classification and some other things, along with new possibilities, capabilities to train for a few scenarios, not all of them yet, to train using the GPU. For example, I have a GPU here, and it's somehow faster to train even for text. Of course, it's even better if you are working with images. So Model Builder has inside the automated ML, which is a library which is able to do some experimentation, but I will explain later. So it's AutoML. Instead of following the entire cycle in training a machine learning model, using AutoML, it's shortening our job by only defining the problem, using the data, and let AutoML to explore for you a good model. I will show you in the demo. So here, for AutoML, we have a lot of features with this new version of AutoML, because it's not new, but now it's improved. We have new library doing that. And now we can create a featureizer. And this featureizer, it's automating data processing and it lets us to identify the type of the columns and predict the type. And it's important for us. I will show you soon in the demo how is that so good. And of course, a few more things to pursue the trials, aka to save intermediary models, and many more. So let's, first I would like to, for those of you who are not familiar with machine learning, I want to show this diagram. We have atop, we have the pipeline. So right behind, we have the data. What do? We split the data into categories: training data and testing data. So we are going to use only the training data to train our model, and we keep away the testing data to validate the model. This is classic, but I'm going fast through this. So after we get the model, we can drop in some data and make predictions. But in addition to that, because it's not only getting the model and we are done, we would like to see what's the accuracy of the model in order to improve it. Because machine learning is not a linear process to get quickly a model and that's it. We want to experience for the best we can to get the best model we can. So it's an iterative process. And for that, we want to be able to, not only to read some numbers, but maybe to do extra miles. And for that, I will show later how we can touch the data set in order to improve our model. How? By reading and by reading some information. But for that information, of course, we have to assemble and to call some algorithms. Part of them are implemented by ML.NET. So at some point, we are using the testing data to evaluate the model, because we don't want to evaluate our model with the same data we used to train it, because of course, it's like I'm agreeing with me always, right? But what about if I'm comparing with something else? So that's why we are keeping away the testing data. By the way, when the accuracy of a model it's 100%, that's bad for machine learning. It's something. It's like Murphy laws of machine learning. It's too good, right? When it's too good, it's something. So I will get through some code to show you first two things. It's text classification and it's AutoML. It's large enough, viewable? Yeah? Good, thanks. So I will go through some important parts. So we are loading the data from a data set, and then we are building our training pipeline. As we can see here, we have three things we are doing. It's converting some text to numbers, because machine learning, it's all about numbers, so we cannot use text. So we are converting the text to some numbers using some techniques. But most important, we are calling this trainer, which is, it looks simple, but behind it, it has a deep learning model with a lot of hyperparameters. But we are calling that with our data. So I will not train again, because I have used a data set which was pretty heavy. Let me open it in Notepad. What do we have here? Notepad, it's not very friendly either. Just let me show you then in dry space. Is data sets here. I think this is it. So what do we have here? It's some quizzes. So we have a quiz, and we have a class for that quiz. This is what we would like to predict for any kind of text. If it's a quiz, but what kind of quiz? I mean, it's biology or math or physics. So this is it. The entire data set, it's pretty large. This is what I try to tell you. So to train entirely model, it takes around 45 minutes. But for that reason, I will just load a pre-trained model, but by me. It was trained by me. So let's load a model and try to predict something. And now, please allow me to brag a little. I have used ChatGPT-3 to generate some data. So I will simply copy and paste. I'm not very convinced. Oh, sorry, this is private. But this is not. So I will put everything in one line, because I'm pasting this in console. So it's one line. So I have this, dropping this. I asked to get a chemistry. So I'm expecting for the model to predict correctly. And the accuracy, the score is pretty good. So it's correct, it's a chemistry. I can try something. Oh, but I didn't want to close. So let's try something which is math related. Right angle. What else? I don't know, a few keywords, right? It's not really a quiz, but it's obvious it's trained and it's predicting nicely the results. If we take a look on some previous data, okay, I will tell you, the accuracy is close to, it's around 89%, which is not bad. It's even better than the accuracy of BERT model, because this is specialized for our data, and our quiz data set, it's pretty good. So that for that reason, it's predicting pretty well. So this is what we can do using text classification. Now, an interesting use case. When I tried to train this model, I trained with the final release, but I think it's a small bug there because it's taking twice as long and the accuracy is terrible, like around 50%. So I found an example which worked well from July, I guess, and then I went back step by step to the most recent preview, and this is working nicely. Yeah, an issue topic is open already on GitHub regarding that. Hopefully, they will find a solution. So if you like to try to play with this, keep that in mind. Don't use the latest, the final release yet. Maybe a fix will come soon. So yeah, so when I struggled to increase the accuracy, I supposed maybe my data was bad because, you know, having a lot of A, B, C for each response, for each answer in the quiz, it's A, B, C, then it's A dot or a parenthesis, all stuff. I had an idea, maybe it altered the quality of the model. So what I did, I have tried to tokenize myself to clean up. And for that, I have created a cleaning pipeline to clean up the text, to get rid of these words from a single letter, like A, B, C, D. And the result was no improvement. I mean, even if I trained later with the good version of the library, I didn't see any improvement in the quality. What that means? That means BERT model is smart enough to not, maybe machine learning will suffer if you have these one letter words when we are doing the classification, but a dedicated deep learning model, it's powerful enough to deal with such words. But it's good. It's good that I was able to use alone ML.NET to clean up my data before sending it to the building pipeline, to the training pipeline. Okay, so this is a text classification using BERT model. I will switch now to the other example. It's AutoML using ML.NET 2.0. And I will try to build a model for this classic dataset taxi.csv. This dataset is very popular, along with Titanic CSV, and there are a few. but they are very popular. So it's regression, so we are trying to predict the price, the fair amount, for this data set. So I will run this this code, and meanwhile I will I suggested 60 seconds training time because when we are doing AutoML, we have to specify how long we like to search for the best trial. So we can put an hour or a minute, but of course we have to find the sweet point. And 60 seconds, it's like a minimum. It depends on the how large the data set, how many features and stuff like that. But meanwhile, I would like to ask you, who played with machine learning before, with Microsoft ML.NET? Okay. What I want to tell, it's just a second to figure out. Yeah, I recall that. A drawback when playing with AutoML was the fact that you had to assemble manually the input and output data models. It's an anemic data model, but still, if we have a CSV with a few columns, we had to write by hand, by GPT-3, from now on, the data model. And it was pretty annoying. Now, with ML.NET, there is a feature called column inference. And let me show you. Oh, I have put it in data, load data and columns. Yeah, so I'm calling auto library and the method infer columns. And this method is looking inside the CSV and is trying to guess the type of the columns. We can save time. We don't have to generate our data model, the models anymore. But still, if we need such models for, I don't know, later for other tasks, because this is dealing with AutoML. But maybe tomorrow you would like to build your own training pipeline and to do this inference again. Well, I have assembled a Roslyn source generator, which is calling the ML.NET column inference, and it's assembling some, yeah, here is very visible. It's assembling the properties, the anemic data models for this, output and input data models. So it looks in CSV and is doing that. For that, I have prepared this simple JSON structure because still we have to specify which is the scenario, how long is the training time, and which is the label column. Yeah, in CSV it's not clear which is the label. Today we maybe want to predict that, tomorrow we want to predict another feature. So either it's inferring the type of the columns, or we are using this source generator. We don't have to write a code any longer. But for some models, for example, for Titanic data set, the column inference It's detecting the source. Titanic. Let me take a look. Let me open the data set. Okay, yeah, it's this. It's survived. So it's survived field or column. It's 0 or 1. This is pretty obvious for us. It's true or false because we are human, but can be string, can be float, can be anything. We know because we figure out from the title. But an algorithm, it's not figuring out what's this column called survived. Oh, 0 died, 1 survived. No, it's not like that, right? So maybe we simply cannot rely entirely on this inference. So we would like to override some types. We can do that as well. Let me check and see if I still have the piece of code. I'm afraid not. But the idea is to work on this column inference results, and this is a collection of features. So you can simply remove some items from a category, and from example from numeric category, and move to categorical category, or to what else? Or maybe the same to decide which is a label. So yeah, actually it's better if I show you here column information. So it's label column. Here we are. So it's label column name, it's numeric column names, it's text column names, image path column names, ignored column names. These which are in plural, it's about those categories. So yes, in that way we can decide manually which column we would like to ignore or to change, to force another category. So having that, our algorithm, it's pretty much prepared to build the model. So I have run this for around 60 seconds, and AutoML tried for us these algorithms: fast forest regression, light GBM, and LBFG. Please forgive me because I'm not trying to memorize what is this. But the idea is these trials are running with different hyperparameters, and now the AutoML is able to optimize even the hyperparameters, which is great, because in that way AutoML is able to find some simply he can find for us combinations of hyperparameters which we didn't try or think about. So what else we can do with AutoML? We can decide which algorithm to ignore, to not use in this automated ML. Maybe, for example, if we know our solution, it's not a linear regression, then we can except searching a good model using linear transformers or trainers. And we save time, right? So stuff like that. So at the end, it was decided the best accuracy for AutoML was fast forest regression with a pretty nice accuracy here. But now, we are developers. We have a model. It's not all we can do. We simply can do something more by simply looking at the numbers. Because most of the time, we don't understand the data. We simply don't see easily patterns in data in order to optimize, to clean up the data set. It's called feature engineering, data cleanup, fancy names like that. But the idea is most of the time we get the data set as it is and we drop there, okay, find me a good model from this sheet. Sorry. So yes, we can do better than that, even if we are not data scientists. And for that, I will switch back to the presentation because I would like to show you what I'm talking about. So where we are now, we have a data set, worse or better, and we have AutoML, and we found a good model. But then, there are a few instruments which we can use in order to look over the data. Permutation feature importance is one of them. And the permutation feature importance, the name is pretty explanatory, but it's measuring the impact of a feature on the quality of the model. What happens if this feature is not in the model? It's measuring again. What is the impact? So do not rely entirely on the numbers, because sometimes in the data there are multi-correlations, but still we can see easily in this data set temperature and luminosity seems to rule, and in the same time humidity doesn't matter for the quality of the model. What that means? That means those last two features may simply be removed from our data set without much impact on the quality of the model. But again, machine learning is about experiencing. So remove, measure, and then decide. Not only remove, because maybe you are losing some important insight, which is, again, it's somehow correlating with some other. So yeah, you have to be careful when you are removing some features. How you can remove? Simply ignoring the training. So this is what permutation feature importance is doing. Let's summarize. Remove irrelevant features. For that, it can be used. And then it's another one called correlation metrics. And now let's imagine a scenario. For example, we have an IoT system where we are reading temperature, but we have two sensors side by side for redundancy. You know, we don't want one of them to die, and we want to read all the time. But obviously, they will being close, and at the same time, they will read the same temperature, more or less. So they are obviously redundant. So when we train a machine learning model having these two columns, obviously we don't need both. One of them is more than enough. And if I'm not wrong, having multiple columns for this, with the same data, this can put some more weight on this kind of measurement. It has an impact on the model. So correlation matrix, it's basically a heat map showing how correlated are these features one by one. And that way we get this matrix. So if we have two features which are strongly correlated, we have it's normalized. So we have a 1 if it's strongly correlated, and we have 0 if it's no relationship. And how is this matrix helping us? It's pretty obvious when we have such redundancies. So for us, that means where we have something close to 1 or something invert correlated, which is the same, we can decide, okay, maybe we don't want to keep both. Why would we like to do that? To reduce the dimensionality of the machine learning model. It will train faster. That's a fact. It's math. And but not only that. As I said, maybe it's somehow unbalancing the model if there are those redundant features are still there. So this is a correlation matrix doing. Let's summarize. Permutation feature importance. It's good for removing irrelevant features. And correlation matrix is good for removing redundant features. So these are two instruments along with AutoML, which we can use as developers to increase the accuracy of our model. This will guarantee a better accuracy. Well, not. It's a suggestion. Try to remove this because it's very probably it will increase the quality, but still we have to see. So I have run all this, and let's see what we found. Well, we found for taxi data set, it says the payment type, if you paid cash or by card, doesn't count for the cost. And that's a fact. Or the vendor ID or the passenger count, at least for this data set, does not have an impact. So according to permutation feature importance, we can retrain our model without these three unimportant features and see if the accuracy is better or not. If you have just a few, I don't know, 100,000 of rows of items, less data, you have to be very careful because when you are removing this, you are easily introducing bias. But I promised you don't have to have data science knowledge. I don't have either, but I got a few things working with that. Simply running this, we can tell, yeah, we can get rid of these columns. And running correlation matrix, it says, look, these two columns seems to be very correlated. Will I remove them? Well, if I'm trying to predict the fair amount, no, because one of them, the fair amount will be our label. But still, for some other scenarios, the larger the distance, the higher the amount, it's directly, they are varying in the same time, very correlated, close to 1. Let me run another sample to make it even. Look, I'm putting this data in AutoML. I'm running again this. Let me build first so the Roslin source generator kicks in to generate the models. I need those models. I cannot rely entirely on inference. I need those models to calculate the correlation metrics in permutation feature importance. They are not, they don't benefit from the support of inferring. So, sorry? Oh, thank you. Thank you. Yeah, now it's good because it's multi-classification. It's nothing else. Yeah, let's leave it because it's only 1 minute. So now what we are expecting, again, the best trial along with its accuracy, and then some irrelevant features and some redundant features, if any. Now, if you ask me if this permutation feature importance and correlation metrics are part of machine learning, the answer is yes, but they still need some work. I mean, you cannot simply call them. It's not one line. You have to know how to prepare some parameters. So it says the best, it's light GBM trainer. And what else? Oh, look, now I have this problem. I don't know. I'm afraid I cannot. I'm afraid this is a bug because sometimes it's when it's trying to okay, let me skip the evaluation. Maybe I can trick this because I don't want the evaluation part, only the building of the model, and then I want to see the permutation feature importance and the correlation metrics. So let's give it one more try. If you allocate more training time, the permutation feature importance measurements are getting more precise. So yeah, you have to, for such a scenario with this data set, I would allocate 10 minutes, not 1 minute, in order to, even if it looks like it's figuring out quickly what trainer is best. Oh, again, I have this. Well, getting stuck in this bug. Let's try another data set, Titanic. But Titanic, I'm afraid it's not very productive in terms of permutation feature importance. But nevertheless, let's run it, at least to wash the shame of the previous data set. To to finalize in glory, not with the failure. Machine learning, it's the team, it's investing a lot of work. They are trying to integrate now a lot of things, and it's a work in progress, so it's somehow normal. But you can contribute if you want to help. For example, in the team where I'm working, I suggested to use machine learning because we have some microservices. And using machine learning, collecting some data about the microservices, the performance, because we are processing some large data, we can predict how to scale, how many instances we want from this microservice or from this using machine learning. So this is so easy to integrate with .NET because it is a .NET application. Well, as I said before, we can see here a pretty good algorithm. Titanic CSV, it's a data set which is, again, very popular, and on Kaggle, which is a dedicated community, and the website kaggle.com, there are some contests. Who is able to train a better model? Because it's free to manipulate the data set, but still you cannot go much. I think the breaking record is somewhere close to 90, but 81 it's good, because if you try to get this accuracy manually, but simply choosing the trainers from the catalog, it's not so easy, because there are a lot of hyperparameters which we simply don't try. But for the computer, it's easy because they have all the time in the world. It's not like manually stuff, right? So yeah, we don't see candidates for irrelevant features or for redundant features, but still, these instruments, I think, are very useful to have in order to create a better model, machine learning model, for a developer. Okay, let's go back to the presentation. I think we are pretty much at the end. And Q&A, if you have questions, please. Oh. Thank you.
Are there any questions?
Please. Oh, okay.
Yeah, I have one question. You mentioned you wanted to scale your microservices, like the number of microservices you wanted based on a model. I was wondering, how would that model look like?
Can you speak loudly? I cannot hear.
How would that model look like when you want to train it to scale based on like the number of microservices that you wanted to scale to?
How would that model
look
like? The scenario, it's clearly a regression. We are trying to predict how many instances of such thing will solve our problem by, I don't know, by trying. It's still the biggest challenge in machine learning. It's to identify the problem. If you are, it's clear what is the problem, then it's pretty easy to build training pipeline indeed.
Mm-hmm. So how would that training model look like in your case?
Well,
what parameters did you look at?
Well, having mostly numbers, maybe what we can have there, it's how long it takes to process a request, how long it takes in each microservice to find which is the bottleneck. So the one which is the bottleneck, it's a good candidate to scale up. This is pretty linear, but I don't know, maybe we can figure out, maybe we can figure out some more complex scenario. But here it's kind of pretty simple linear regression stuff. Welcome. Yeah.
My question is regarding data labeling. Have there been any improvements maybe on helping out how to label your data, or maybe how much actual labeling you need for a decently training a model when you start, let's say, investigating? For example, we tried training a small model based on spike detection, trying to detect spikes of meter values, let's say,
Okay.
and energy measurements. And the data volume that we had was huge. So labeling that is always a really difficult task.
Manually.
Yeah, that's the problem.
Okay. I'm not a specialist, but when I try to get some labeled analytical data, it's not easy. So the best scenario is to know in advance. Let me give you an example. If you are trying to find, maybe you have two categories, safe and danger. So it's to train, to acquire some data when it's danger. Now all this data, it's read for the danger scenario, and now you know in advance these are all labeled as danger. So it's like pre-labeling. But what else? It's real-time or near-time labeling. That's a bigger challenge, but it still can be done using computer vision. For example, a human, it's not a good idea to stay in front of the sensors and to figure out which category it's the scenario now. But a Raspberry Pi with the camera, it's okay. For example, if it's again trying to find if it's a danger, if it's danger or safe, and it's looking at the image and it sees fire, it will identify this is how it looks when it's danger. This is how the sensors look when it's danger, because I'm seeing fire. So it's like, of course, it's very custom solution, but for important things, this is how it works with customized solution. So this would be real-time labeling, and it's post-labeling, but still we need some to record somehow the environment.
And
It's pretty much the
some
same.
feedback back to basically.
Yeah, I had a presentation when I tried to mix machine learning with deep learning. So a Raspberry Pi was reading the sensors data, and the camera was looking for the scenario. And I had a lighter, a torchlight, and the image classification was able to detect, okay, look, now I have a lighter, and now if I see here high temperature, obviously it's a lighter. But if I using an infrared torch to fool the sensors or whatever, something similar, but the camera doesn't see anything. So what I'm saying, we need to put, if not a human, to put some computer vision there to help us. But yes, the labeling, it's very hard, if even harder, because for images, we are using human. we pay them with a few dollars per hour, and they are labeling images, but they have their own deep learning model there in their brain, trained from the moment of birth to identify things with their eyes. We don't see numbers. Neo sees numbers, Keanu Reeves, but we don't see numbers. We see images with our models, what we are with our image classification model, right? So that's why we can use people to do that. But for numbers, we don't have such. We are not born with such models in our brain. Indeed, then we can simulate that using deep learning. Mm-hmm. Okay. Okay. Thank you. Yeah.
For learning the model, generally there is like CSV. Is there any possibility that we can also have a model that is more like a visuals or images, something, and then we can identify like the image detection basically? Is that possibility using?
So if it's okay,
Is
I'm
it
repeating.
possible,
So
basically?
if it's possible to use for image detection other than images.
For
So
example,
what? For image, no, because the image detection, it's working with pixels. And it has layers which translates to small shapes, then in larger shapes, and then it's trying to recognize some basic shapes from real world, like squares, and then it's parts of body or objects, and then it's a certain category, like wolf or car or something else. So a machine learning, a deep learning model which works with images is expecting two-dimensional data. But on the other hand, you can work with sounds in an image manner way. So you can transform sounds by extracting the histogram, which is like like a diagram, and use that to do image detection and identify sounds, words. It's interesting. I saw some examples. Welcome.
Thank you very much.
Thank you very much.